Hello students, this is the video number 41 of new chapter Current Electricity Part A for Class 9 Physics. In this chapter we will discuss about electric current, that is the rate of flow of charge. Electric current is represented by I is equal to Q upon T. I is for current, Q is for charge, and T is for time. SI unit of current is ampere. SI unit of charge is coulomb, and time is second. So if you want to define 1 ampere, it means if the charge through a wire which flows, that is 1 coulomb in 1 second, it means how much current is passing through the wire, that is 1 ampere. After that, source of current is there, that is one is cell and second one is electric means. So cell is of two types. One is primary cell and second one is secondary cell. Primary cells are those in which chemical reaction is irreversible. Irreversible means once the potential energy which is stored in primary cell is used up, that you can't further used. You have to throw it. And second is secondary cell, in which chemical reactions is reversible in nature. Reversible means once the potential is used, you can recharge it again and again. A very simple example, in these days we are using mobile cell. So mobile cell battery is the example of secondary cell. Okay. So primary cell examples are dry cell, Daniel cell, named after the name of the scientist, and even Leclanche cell. And for the secondary cell, the examples are lead acid accumulator, lead or acid accumulator, lithium hydride battery, okay, LiH, lithium hydride battery, and then nickel and iron cell or accumulator. You can write accumulator also. Nickel or iron accumulator. So these primary cell are the light in weight and cheap in cost, but secondary cells are heavy one, which can give you heavy current, and they are even costly. The next is current is a scalar quantity. As you know, I is equal to Q upon T, but we know that according to the quantization of charge on any unknown body is equal to Ne. Okay, and even plus minus will also come. Plus is for loss and negative is for gain of electrons, where N is number of electrons, is magnitude of charge of an electron. The value is 1.6 into 10 raised to power minus 19 coulomb. So there is one question: find the number of electrons to make 1 coulomb charge, or how many electrons are present in 1 coulomb charge. So how to get that? From this solution you can write N is equal to Q upon E. We are interested to get N. Q is equal to 1 coulomb and the value of E is 1.6 into 10 raised to power minus 19. This coulomb will cancel, and this 10 will go up, and 110 I will use from this plus 19 to this side, it will become 100. And if you solve this further, you will get N equal to 6.25 into 10 raised to power 18 without any unit, because this is merely a number of electrons which are required to make 1 coulomb charge. After this, symbols used in circuit diagram. First is for ammeter. Ammeter is represented by this circle, and inside it you will write a capital A. To one side you will have positive terminal, to the other side you will have negative terminal. So ammeter is used to measure current in the circuit, and always connected in series in the main branch. Second, about the voltmeter. Now voltmeter is represented by, inside the circle you write V, and to one side you will have positive and the other side you will have negative. Voltmeter is used to measure potential difference across the load. The resistance, it is always connected in parallel. Third is galvanometer. Galvanometer, write in this way, it will not have any positive and negative end. It is used to measure current in the circuit. Fourth one is key. So there are three keys that I made. One is plug key, this is switch, and this is tapping key. All are representing the open kind of keys. Plug key is also open, switch is also open, tapping key is also open. But if you want to close it, inside the bracket you have to mention one dot. This is the closed plug key now. And here this gap is connected with the second terminal. This is the closed switch. And third one, this arrow will come in contact with the second terminal. So this is the closed tapping key. Fifth one is source of current, that is cell. It is represented by one long and small line. Long is representing an anode and small one is cathode. Then there is battery. Combination of number of cells. So I am using here 4 cells, 4 cell battery. Sixth one is rheostat, variable resistance. It is represented by this zigzag line and then one sliding contactor of jockey, which is used to select the length according to which resistance will be selected. As you know, resistance is directly proportional to length. More length if you select, more resistance can be selected in the circuit. So high resistance means low current. Seventh one is load. Load is a kind of resistance. It can be bulb. So bulb will be represented in this way, and can be a heater also. Heater. So it will be represented by the zigzag line inside the circle. So this is heater. And after that, connecting wires, which is made up of copper, to connect the different electrical components. So it is represented by a straight line. Just read the content properly from the book and practice all these representation of different electrical components. Thank you very much.